How'd you guys go with the 1170.2 wind?
Yeah.
Up
All
to
right.
the questions.
Yep.
Right.
Okay. Do you want to answer questions about the topic, or should we go through a works problem?
Are the word problems in the questions on the topic?
Yes.
Yeah.
So the works problems, there's first a bunch of multiple choice questions, and then there are a couple of calculation questions.
I think it would be good to do a quick run over of what
Sure.
we're learning.
Okay. So we're going through 1170.2, which is wind. There are actually two different wind codes in Australia. One is 4055, which is wind for housing. This is wind for structures in general. So this is the more comprehensive, more complicated document. So get to know this one. And this covers, like every code, it starts off with a scope, which says what it's for and what it's not for. And it says buildings and towers less than or equal to 200 meters tall. So if you are building a tower more than 200 meters tall, this is not for you. Structures with unsupported roof spans of less than 100 meters, happy days. Offshore structures within 30 kilometers of the nearest coastline. Other structures apart from offshore structures, stuff like that. Wind farms, so on. So it's covered everything I've ever designed. I've never designed offshore structures or towers more than 200 meters tall or anything like that. So it's a lot of stuff. Now, in designing the wind or using the wind code, there's basically two halves to this problem. The first half is determining wind speed, and the second half is determining the effects of that wind on what you're designing. Okay? So go one. Determine wind speed. And then two, actions from the wind. Okay. Whenever you do design a structure for wind, there are a lot of calculations involved. They're not all of them are difficult ones, but there's quite a lot of things. Because when I say determine the wind speed, that's the winds from a certain direction. It's going to blow different speeds from different directions. Okay. So let's determine the wind speed. You go to chapter 2 or chapter 3 to determine the wind speed. Contents are there. Chapter 2 is all about chapter 3. Chapter 2 and 3. There you go. Chapter 2 is general. And we start off with an equation. Here we go. There's the site wind speed. That's not the equation I want. No, let's go there. The site wind speed. So let's do that. Site wind speed is everything to do with the wind speed is V. In this situation, there's lots of little subscripts, especially in AS4100. Some of them change partway through too, so you gotta watch out for that. But VR is different from a VU, different from a V situation B. Okay, that equals VR times MC times MD times MZ cat times MS times MT, and I honestly don't know why they put brackets around those, but they do. So we've got to work out what each of those things are. All right. So the first, basically, work through the code roughly in order. This one's a relatively well laid out code. Not all of them are like this. Some you have to swap back and forth between different bits. And so there's a table called table 3.1 where VRs, a whole bunch of VRs are listed. And it says regional wind speeds Australia. And we've got V1 up to V10,000 and region A, B, C, D. So you go, oh crumbs, what region are we in? And you would have seen in here somewhere a map. There you go. On the next page is a nice map of Australia. And you figure out where you are on the map, okay? Which means that when you're designing a structure in Bathurst and you take it to Darwin, you've got to redesign it for the wind, if it's a wind-sensitive structure, because the wind blows a lot harder up there. In fact, you can see basically around the north coast, it's pretty bad. Most of Australia is region A0, southern bits A2. And so what you find on this table, and so yeah, there's B, C, and D. What you find on the table is that regions A, you have wind speed A 1 to 5 of that. B, wind speeds are higher. C, wind speeds are higher. D, wind speeds are higher still. Okay, D, we're talking about cyclones coming in. All right. So that, oh, not quite. We have to work out what the number. Are we going to use a V1 or a V10,000 or something in between? Looking for answers.
Depends on the importance of the structure.
Depends. Yes, thank you. Depends on the importance of the structure. Let's assume our structure is a nice signboard somewhere in Bathurst, which is 2 meters tall, and let's make some easy dimensions. Make that 1, make that 1.5, or make that thing 2 meters tall. And there's the ground. All happy with that? Okay, and we're in Bathurst. So we are in region A0. I have to keep putting glasses on enough. Thanks. We're in region A0. And importance level of this structure. How important is this structure?
Low.
It's low
Depending
importance.
what's on the sign.
Yes. So depending on what's on the sign. Oh, I hadn't thought of that.
Well, it could be like danger, road's not finished. Someone goes past the sign and they
Fair enough.
crash into a culvert.
In general, for buildings, I have to check if this counts as that or not, or if it's a completely different system. For buildings, we categorize in 1, 2, 3, 4. Where category 1 is a farm shed, where if it collapses, probably no one was there to see it. Okay, it causes relatively little harm. Category 4 is things which are essential for post-disaster recovery. So that covers your hospitals, it covers your power stations, it covers your critical infrastructure, it covers the ambulance parking bay, okay? I picked that example because there's a very famous picture from a California earthquake where there was a row of ambulances all parked in their concrete shed. The earthquake came, collapsed on top of all the ambulances are out of service, all right? If you're parking an ambulance in there, you need to be able to use that ambulance post-recovery, okay? So that bumps it into 4. Category 3 is any structure that holds a lot of people. There's guidance in the commentary about what is a lot, okay? Shopping centers, this building might be a 3, probably is. Certainly, because it's big enough probably in the hall to have a lot of people, counts as 3. And category 2 is everything else. Houses, smaller buildings, whatever. This is category 1, and it's in the topic there. If you look at the table from the National Construction Code, it then says what you should use as a wind load. And that gets modified a bit. If this is a temporary sign, it's only ever going to be there for a month, then it's a bit different to whether this is really a permanent sign. Okay, yep.
So take into account what would happen if it did fall. Like if it's a sign and it's made out of wood and it falls on someone, it's probably not going to injure them too much. Like, does it take that into account?
Yeah, a little bit. It's got to be, like, there's only 4 thresholds between pretty harmless and, nuclear.
Yeah.
So it's got to be pretty significant. Most signs like that are going to be a 1.
But if it was like a street light with a sign on it or something, it was huge and could pull down the motorway and kill you, would that be more?
I'd struggle to put a sign being 2. But if you think it's a concern, you can make an engineering judgment about that, bump it up.
Okay.
Like those, you guys from New South Wales, there was the ones on the highways.
Yeah, that's what I was
out of
thinking.
Melbourne, and one of them fell off
Yes.
the beam across.
That's right. Took out someone out in their car, didn't it? Yeah.
Yep.
Yeah, not good. Not a good look. Okay, so if we picked, we're in region A0, V100 is 41. From the table, I've got 41 VR equals 41 meters per second. And that is from AS 1170.2, table 3.1. Okay? when I'm doing calculations, whenever I look up, take out that, whoops, ooh. Whenever I'm writing down a number or calculation, I write where it came from, okay? First time, normally the whole code, and then the clause or table number, all right? So VR is, we've got 41, happy days. Let's look at MC. Turn the page, and MC is, where's MC?
Yeah, it doesn't exist.
Sorry, MC is a new one in 2021 code. It is not in the 2011 code. It's the climate change multiplier.
Right, so we need
Okay.
to add that?
Yep.
So should That's a lot.
Okay. If you look up MC in region A0, MC is 1.0. Okay? There's no climate change in this region, apparently. Go figure. All right, MD is the direction multiplier. And so for MD, here's the table here, table 3.2. It's got a whole bunch of factors between 0.75 and 1. And what that indicates is that the wind blows harder from certain directions than from other directions. Okay? In region A0, the strongest wind is a westerly wind. It's 1.0. A northerly wind is 0.9. So you can actually have a reduced wind speed if you're considering a northerly wind versus a westerly wind.